long, long before Aristotle in Egypt, in Babylon, people discovered this. And even if you have a picture, it's a modern presentation of this. Here is Seattle, and if you take pictures of the sunrise, the exact point of sunrise, you'll see that the point of sunrise is moving, changing, and you can discover when is the equinox and other astronomical events. So, first, the regularity in the sky was the number of days in seasons. We have a seasonal variation. The other problem, which was a big puzzle for astronomers from, say, 1000 BC up to 1600, was a motion that is called retrograde motion. If you follow the path of, for example, Mars, you take picture every day, you will see that Mars starts from here, goes forward, and then suddenly it starts, after, say, 2.5 months of moving ahead, it stops and goes back for 45 days, and then stops there and then continues its motion. It was a big puzzle for all astronomers, from Egyptian culture, tradition, up to the time of Copernicus. This is another picture of this, which is again Mars making a loop. And this loop and the shape of it, the size of it, varies every year. It is a big, big puzzle. Okay. I said that Aristotle knew about this. Aristotle plus Eudoxus, which was an astronomer at the same time before Aristotle, they came to this theory that we can keep the Earth as center, we can keep the uniform motions, but if we have the universe like this onion, and if we attribute different axes for different layers of this onion, then we can reproduce those variations in the motion of the heavenly bodies. Okay, very good improvement, but day by day observations, accurate observations showed that this model is not the correct model. Apollonius in 262 BC, he came up with a different theory. Again, two basic concepts that I explained first, the centrality of the Earth and the uniform circular motions. He put the Earth at the center, and then he said that, okay, we have a planet moving in a smaller orb, which is called epicycle, and the center of this epicycle is moving around the Earth. So, if we move the system, we will see that the planet is making backward motions to produce the retrograde motion. Very good. But day by day, their observations were improved and their instruments were more accurate to find better data and analyze their data in a better way. So, Ptolemy in 2nd century AD, a Hellenistic astronomer, after a long time of accurate observations, he discovered that this model is pretty much okay, but if we want to create uniform circular motions, the center of this uniform circular motion is not the Earth, but a point which is called equant. Equant became the third big puzzle for astronomers, starting from the time of Ptolemy. Why the center of uniform motion is equant and is not the Earth? So, in mathematical side, Ptolemy's model was perfect. Astronomers were able to predict eclipse, to predict astronomical events, to make their calendars based on using these mathematical tools, these geometrical circles and circles. And when you want to use these models, you don't care about the physics of the universe. Where is the real center of the universe, why they are moving around Earth or not around the Earth, and so on and so forth. You are a mathematician, you want to calculate calendar, and this device gives you all opportunity to make your calculations. Now we in fact learned after Kepler why all of these irregular motions happen in the sky. In reality, based on modern physics, we know that the sun is not at the center of the universe. The orbits are elliptical. Sun is in one of the foci of the ellipse. So, sometimes, a planet like Mars, sometimes is further to the sun, sometimes it's closer, and its speed changes all the time. Sometimes it is slower, sometimes it's faster. They didn't know about this. They were thinking of circular motions, and they had to create a clockwork with a lot of gears, a lot of circles to reproduce this circular elliptical motion based on circular motions. Okay? Ptolemy explained his mathematical astronomy in a book named Almagest, which was the Bible of mathematical astronomy for about 1600 years. It is from, in fact, Almagest is from Arabic, Arabic translation of the Latin version of this Mathematicus Syntaxis, which was a Greek name for this great book. Here, everybody wanted to know mathematical astronomy. That was the source book, and for 1600 years, people were using it as a source book. However, Ptolemy had a different book called the Planetary Hypothesis. In Planetary Hypothesis, he is talking about the physics of the universe. Where is the center? What is the shape of the universe? Just forget about those mathematical, those drawings that I showed to you. What is the reality of the motions of heavenly bodies? There, he explains everything based on the onion-like model that already I explained. Just think this blue layer of onion is an orb. Within that, there is another yellow orb. Within that, we have another orb which carries the planet. Planet moves here. This yellow is eccentric, moving around inside this blue one, and creates the motions that we see. And the planet's motion is regular respect to this equant, which I explained, but not respect to the central wall, which is the Earth. Here is a presentation of Ptolemaic cosmology. The universe was like this in Ptolemy's world. So here at the center, I'm going there, is the Earth. Okay. Immediately after the Earth is the Moon. Let me make it a little slower. Okay. Earth is physically, it is embedded inside one of these layers. And that layer is embedded inside another layer, another layer, another layer, and finally we reach to the fixed star.